to get started. So first I want to mention, what should you have to turn in tomorrow? Yeah, so make sure you get on Canvas. Even if you've emailed me pretty earlier in the semester, some of you, just upload like a quick couple sentences about your project idea, kind of mentioning some of the variables you think that you might need, and get that uploaded to Canvas. I think in the syllabus, and the first day I said by 5 o'clock, but really just by the end of the day tomorrow will be fine. So I think I have the time set on Canvas to be the end of the day. So we'll pick up where we left off Tuesday. Get out of that. I'll get some of the files open. So I think we stopped on talking about kind of game theory. So the next kind of topic that we'll dive into, and we've talked about this a little bit kind of indirectly, is competitive balance. Okay, so all competitive balance means is kind of how much variation is there that exists in the league, right? So we think about kind of having parity in the league. That would mean that we have pretty kind of constant quality across all the teams in that league. So we're hoping for parity. We're hoping to improve competitive balance, right? We want competitive balance to be that we have teams that are more kind of equal quality than a wide variety, right? So we'll talk a little bit about why leagues might want that in a second, but we're first going to kind of dive into ways we can measure this, okay? So what statistics might we have talked, or might you be aware of, that would be a way to capture kind of the competitive balance in the league or measure variation in quality? If I have the wins of every team, or every, if I think about a team, some individual sports, maybe the players, what are some statistics I could use to measure variation? You don't remember anything from 221? The variance, all right, standard deviations. Even just simply looking at, I think I have the range here, right? Even if we just look at the range of the data, right? What's the difference between the number of wins from our highest quality team, or the team with the most wins, and the team with the lowest number of wins, right? What's that range that we see in performance, right? We can also, there's issues with the range, because just because you have, one really bad team, that might cause the range to be really wide. Well, if the rest of the teams are all bunched together, well, that's good, right? So we can capture that with things like the variance or the standard deviation. Okay? So a lot of this we probably won't be doing manually. I might show you a couple examples how we could do this in Excel. But once we have those statistics, we need to know how to use them. So the variance and standard deviation range, basically all of them, as they're higher, right, as all those statistics get higher, that tells us there's more variety, right, or there's more, the teams are kind of more spread out in their quality. So we want those to be lower, right, if we want to improve competitive balance. What are we going to be taking the variance of? I've kind of, already kind of alluded to, usually we're going to be looking at like the difference in wins, right, or the variation or the variance in wins, but that might not capture everything, right, because just because we see, the variation, the number of wins across every team go down, if we have the same one or two teams continuously, winning championships or winning the division, well, that's not a lot of parity in the league, right? You're not getting a lot of variation in kind of who is the top performer in the league, right? So there's maybe multiple levels we want to measure to see if there's competitive balance. Okay? And these are some of the things you could think about. I don't know, if we want to think about championships, it depends on what sport we're talking about, like World Series winners. Maybe we're not even maybe we're not just concerned with who's winning the World Series, but which teams are in the playoffs every year. If it's the exact same teams, we could measure how much variation there is in the number of like new teams, or the number of teams that are in the playoffs in the current year that weren't in the prior year. So there's a lot of different things. We get a little bit creative with this, okay? So those are kind of the ways we'll typically measure competitive balance. But why would the leagues care, right? Well, one thing that could influence the demand curve, right, is whether or not there's parity in the league. So I think I have it here. Yeah, so I have a paper here. We won't open up, but if you're interested, you can kind of click on the link and pull it open. But basically, the summary of it is that individuals value watching something more, right? Their marginal benefit increases if the outcome is more uncertain. Okay, the example I would give for this is, if we got to me, would people want to, I don't know why anyone wants to watch golf on TV personally, but if you like to watch golf, right, you'd want to watch, like, I don't know, Phil Mickelson and then Tiger Woods go up against each other, right? If it's Tiger Woods against me, nobody wants to watch that because they already know the outcome, right? They already know the outcome of that event, right? That's why, we have these kind of, look at games where some of the higher quality teams in the league are facing the lower quality teams, attendance, viewership, a lot of those things are down. Right? Because people want an event they don't know the outcome of, or where those two teams, right, or if it's an individual sport, those two individuals are similar in their quality, right? And, there's a lot of people, this is papers specifically, they've measured this, right? They've looked at things like ticket sales, attendance, TV viewership, and people's actions kind of support this idea, okay? So the demand curve is then influenced, like each game, the demand curve is influenced by whether or not there's kind of a closeness and quality of those participants, those players, or those teams that are going against each other. So that's why the league wants to kind of make sure that it has more parity in the league, or improve the competitive balance. Okay? So one issue that we've kind of already alluded to this, but it's kind of difficult for the league if you've got some teams win maximizing, some teams profit maximizing, right? We talked about one way, right, with revenue sharing, which we can kind of reduce potentially the gap in the number of wins, right, if that's kind of our measure of competitive balance. Well, that works, but remember we said with revenue sharing, if the small market team is profit maximizing, what do they do with the additional money? They just pocket it, right? They don't spend any more on their team to try to improve their quality. And so, the leagues are somewhat constrained with just using revenue sharing. So we'll think about some other kind of issues or some other things that the league could do to improve this, right? So, what's, maybe a good evidence of competitive balance influencing how much money a league can make? So if we go back from 1950 to 1958, I guess I should probably pull some recent numbers. You could probably do something similar with the Patriots, although they kind of span a larger number of years. But within that time period, the Yankees won 6 of the World Series, right? So, this is where it doesn't matter what the competitive balance in terms of wins looks like. If we had the variance of wins back in this time period, who cares if the variance was getting higher? The same team was kind of continuously winning everything, right, or winning that World Series. So if we look at American League and then kind of New York Yankees games, we actually see that they decreased attendance over this time, right? So the National League maybe wasn't as impacted by this because at the time they only played National League teams. The Yankees weren't part of that picture. There was still some competitive, better competitive balance within the National League. So we can compare the National League to the American League. The American League, all of those teams had to play the Yankees, and so if everyone thinks that the Yankees are always going to win, right, that outcome is pretty certain, then people aren't going to be as likely to watch those games or purchase tickets and attend that game. So here's kind of someone had put this together, some of the old data from this time period. So we've got every single year who the American League champion was, who the World Series champion was, and then what the Yankees attendance, the American League, and National League. So we just kind of look at this and kind of analyze these numbers. First of all, in these first 4, you can kind of see here, the American League champion every year was the Yankees except for 1 year, right? So if we're looking that there's no turnover at the top, the American League here has no competitive balance. Right? If we look at the World Series champion, we start to get a couple years where the Yankees aren't the World Series champion. Even though they're kind of winning the American League, the National League teams at least are of somewhat higher quality and able to compete with them. Okay? So if we look at the attendance trends here, initially, right, this is kind of a weird period, but the attendance was the first few years decreasing across the board, right? Yankees attendance was decreasing, American League attendance was decreasing, and the National League was all decreasing, right? These might have been outside factors, right? That was kind of causing a trend in all of them. Around 1953, after they've kind of established, right, that they're one of the higher quality teams in the league, notice what starts to happen. Well, there's still no competitive balance in the American League. So they kind of start to see their numbers are still decreasing, and they start to increase here a little bit and kind of remain constant. But if we look at the Yankees attendance, it continues to fall, and then it also kind of plateaus, right, a little bit. But if we look at the National League, right, they start to see an increase in their attendance, right, and a pretty big increase towards the end, right? And this is likely because the Yankees weren't, we have a nice comparison group here where the Yankees weren't part of the National League, or they weren't playing in these games. And so this is kind of a nice, kind of easy evidence that, yeah, if you don't have any turnover at the top, if competitive balance is bad in the league, you're going to see a loss in attendance. And a loss in attendance means a loss in revenue, loss in profits. Okay? Now, it could be, right? It's hard to look at just these numbers. We'd have to do a much more in-depth analysis, and that there's a lot of other things that probably matter at this time as well. Populations were increasing, right? So even if the competitive balance was driving demand down, maybe the increases in population was driving it up, right? So it's kind of hard to really say this is for certain telling us that, but it looks like some pretty good evidence, right? Especially because any trend we would have in the American League, we'd also have in the National League. And we see here the National League was trending upward, and the American League kind of trends downward and then kind of remains pretty flat, okay? Any questions on this idea of kind of competitive balance or kind of that little example there? Okay. All right. So, one of the issues that we've already kind of been able to analyze looking at the win market was this idea that another factor that's going to play a part in kind of the optimal number of wins a team targets and subsequently competitive balance is market size, right? Population, the income of the city that the team is located in. Is it a large or a small market team, right? So we've already talked about this, is it the city? Are we really going to just measure this using the city's population? Well, that might be good, but some cities, the metro area is significantly larger than just the actual city limits, right? I think if we could probably Google it right now. I think looking at some stuff. So if we go like Indianapolis, well, let's use a bigger city. Let's go Chicago population versus metro population. So, all right, if we get an estimate, there's about 9 million people in the metro area. Let's see. Should we use Wikipedia? Probably not, but this is just the Chicago metropolitan area. So we got 9 million people in the metro. Chicago city population. And only about 2.7 in the actual city, right? So there's extreme differences in those two things sometimes. So when we're thinking about market size, we got to think about how we're actually measuring this, right? The metro area is probably still people who are very likely to attend those games. And so we got to be careful about just using city size versus metro size. What's the broadcast area, right? Are there nearby teams that are going to be kind of overlapping, in around my region that are also going to be competing with me, for TV spots? Am I able to get my games out across country? If we think about some differences there, what's one team that might have a really large market size? So I always like to use NCAA college football for this. So Notre Dame, like for the longest time, where it had this kind of, was always on TV, and they had a pretty they had a pretty wide reach across the U.S., right? And so a lot of these other teams, maybe of similar quality or even size to Notre Dame, weren't getting broadcasted across the country as much. And so if we think about there, Notre Dame would have a much larger kind of market size relative to even a similar, college in a similar size city, right? Because they're just not getting on TV as much. Okay? So with these ideas, do we really want kind of this like a perfectly competitive league, right? Do we want competitive balance to be perfect, right? As low, every single team is the exact same quality. Well, if quality of a team also impacts the demand curve, right? People are more likely to attend a game if their team is doing well that season, right? Or is kind of having, performing very well. If we then think about which cities would we want the best performing teams to be in? Yeah, larger markets, right? because that's going to, we know larger markets have higher additional revenue per win. And so we don't really want perfect competitive balance, because if we start to reduce the number of wins from a large market team, we're going to lose out on a lot more money than the money we gain from that small market team doing better, right? In fact, I'll switch over. I can kind of give you something we've already talked about, and then hopefully, did I not switch over? It says it switched over. Oh, maybe it's because I got to do that, right? So, if we think about what we were talking about before with the win market, and I'm just going to keep marginal cost kind of constant here just to make the model a little bit simpler to look at. So we go, here's the demand curve for a small market team. Here's the demand curve for a large market team. If we think about each number of win kind of representing, this is like average total revenue for a small market and average total revenue for a large market. If I look at the same number of wins, I'm going to extend these demand curves a little bit. I don't know, we can call this however many wins we want. Let's call this 10 wins, right? The average total revenue earned from that 10th win is much lower in the small market team than the average total revenue, right, earned from that 10th win in the large market, right? So we're, even if I, think about here, well, is it okay? I'll increase them by 1, right? That means I'll lose out because let's say we only have 2 teams in the league. We'll keep it easy, right? That means now this team's only going to win 9. This team's now going to win 11 games. Well, the average total revenue we earn from that large market team winning 1 more game, making competitive balance technically worse, and the small market team, right? Well, we're actually losing out on the average total revenue from right here, but this is a much smaller loss, right, than that much larger gain, right? So, we don't really want perfect competitive balance, right? We probably want those large market teams, if we're being honest, if the leagues are being honest, to actually perform a little bit better, right? That's better overall for the league, okay? Let's go back here. Sweet. So, this is kind of what I just said, right? We want, the large market teams in theory to be performing a little bit better, okay? So one way we can measure this competitive balance or kind of competitive imbalance is with a standard deviation, right? So the equation that we typically have for the standard deviation or the variance, you go through, if you have a data set, you go through every observation, you take the value for whatever variable you're interested in, you subtract the mean, kind of 0.5 here, and then you square it, right? Well, if we did that for every single team and then added them all up and divided by the number of teams we have in that league, that would be the variance in win percentages for our league. Right? Because we know, and here's a kind of this might not be obvious, but the mean win percentage has to be 0.5, right? Because for every game that's won, there's a game that's lost, right? So if you look across every single team, the win percentage in the league will always be 0.5, right? Because if you look at a league where there are ties, this becomes a little bit more complicated. For the sake of my discussion right now, think of a league where ties don't exist, right? You always have overtime where there is a conclusion to the end of the game, okay? So this will kind of give us the variation that exists in the league, and then taking the square root, that simply gives us the standard deviation instead of the variance, right? This calculation here is the variance. Taking the square root gives us our standard deviation, okay? So the higher this is, the worse the competitive balance is. The closer this gets to 0, right? A perfectly competitive league would have a standard deviation or a variance of 0, right? Every single team would have the same number of wins and the same number of losses. Every team would go exactly 500, okay? Now, we already talked about we don't really want that, but if we measure this across the different leagues, and I think here I had 2016, I thought I updated these to 2018. I might have just forgot to select the year, but pretty recent numbers, and we could actually go out and, the last year is kind of tough to work with the most recent data because we had, all the COVID stuff, and there are, different teams for different games. But if we go back to the last full season, right, we could redo this pretty easily. Honestly, you could just go to like ESPN, copy and paste the win-loss records of teams and create this for Excel pretty easy. So we kind of see across the leagues here that it looks like, oh man, there's a ton of variation in the NFL, right? A much higher standard deviation than there is in Major League Baseball. And then kind of these two are somewhere in between. NHL and NBA are somewhere in between that. Right? But you can't really, it's not really comparing apples to apples here. Right? Because if you think about the NFL, they've got 16 games, right? So if we think about losing, we're winning one additional game or losing one more additional game, that's going to be a much larger swing in the win percentage, right? So this win percentage, we could calculate in Excel right now. I'll use Excel as my calculator. You guys don't want to see this stuff. This is binomial distribution stuff. So we'll zoom in here, right? You can kind of think about, what is 1/16? If I win one more game, that's going to increase my win percentage by almost like 6%. But in Major League Baseball, if I win one more game, it only increases my win percentage by 0.006, right? So just by the fact that there's a higher number of games, right, each additional win won't impact that variance near as much. So it's not overly surprising that we see the NFL have a larger kind of variation there. It's just kind of a byproduct of having a fewer number of games. Okay? So, right, if we're trying to measure this, we already kind of answered this question for us, but because we see this, higher variation, how can we maybe, how can we manipulate? How can we alter that statistic so that it's then comparable across leagues? Okay. So what we can do is say, well, look, there is an ideal standard deviation that each league would have, right? I said that if it was perfectly competitive, it would be 0, right? But even if you had teams that were all of equal quality, just by chance, occasionally, like they're not all going to go, exactly 500. One season you might have one team win one more game and one team win or lose one more game than every other team. Maybe one year you have 2 and 2, right? There's going to be some variation or some distribution that exists, even if every single team is of exact equal quality, right? Because someone has to win and lose the game. Right? So you're going to have a distribution. We won't go too much into the kind of mathematical kind of proof of this, but what ends up being true is that the standard deviation that would be ideal, right, in every single league, or kind of if they were perfectly competitive, what you would see is that distribution, right, is going to be different depending on the number of games you play. So your ideal standard deviation will be 0.5, but then part of that equation is the number of games will influence what the ideal standard deviation is. Okay? So we can kind of walk, actually, interesting enough that I pulled up in the binomial distribution stuff in my stats class earlier, because this does come from the binomial, right? You either win or lose, so there's 2 outcomes, and you can work through the mathematical proof that this would be your ideal standard deviation. So, the NFL, we would plug a 16 in here, 16-game season, get their ideal standard deviation. MLB, we plug in 162, right? Oops, and I'm going to go sneak ahead here for a second. Ignore this. So we could compute the ideal standard deviation for each of these leagues. Notice the ideal standard deviation, much higher in the NFL than the other leagues. NBA and NHL play the same number of games, so we have a kind of equal ideal standard deviation there. Right? And then MLB being the lowest, playing 162 games. Okay? What we're then going to do is take this ideal standard deviation and take a ratio of that relative to kind of what the actual standard deviation was in that league in that year. So the ones that we calculated in the prior slide, right, divided by this ideal standard deviation that we then kind of just talked about how we calculate it. So this ratio, right, if it was 1, that would mean that the league, right, how would I get a 1 here? Well, it would mean that the standard deviation I see for that league is exactly equal to that league's ideal standard deviation, right? And then as that standard deviation increases, right, competitive balance moves away from this ideal kind of point, my ratio is going to get larger and larger. So the lowest this ratio can be is 1, and that would be if we are hitting the ideal standard deviation perfectly, right? anytime we move away from that, the variance can only move up, right? Variances and standard deviations, the lowest we can see is 0, and then they kind of increase from there. So as this goes up, our ratio gets worse. That would mean we have less competitive balance. So we look across the leagues here, take those standard deviations I gave you that we calculated, and then the ideal standard deviations for each league, the ratio of those two. We can kind of see now our story changes, right? Now the NFL is actually looking a lot better than the NBA or the Major League Baseball, right? Their ratio is actually lower than those two. In fact, the NHL actually has the lowest, right? You can kind of see here the NBA is doing a pretty bad job. I mean, I shouldn't say they're doing a bad job. In terms of competitive balance, it's not great. I mean, this is significantly higher. At least the other three are kind of in the same ballpark, right? And we talked about, like, we don't really actually probably want the ideal standard deviation. When I say it's the ideal standard deviation, that's the ideal standard deviation to have perfect competitive balance. We already said we don't really want perfect competitive balance because we want those large market teams to do a little bit better. You know, I don't think the NBA probably has a leg to stand on that to really say, well, no, we have actually more teams in large markets. That's why our ratio is so much higher. They don't, right? In fact, you know, I think Major League Baseball would be the one that probably has the best argument for that. They have a higher percent of their teams are probably in large markets. Yeah, that would be, that's as best we can do, right? That would be perfect competitive balance. And that's where we said, if we calculated that, if every single team went 500, what would my standard deviation be? Not 1. My ratio would be 1. My standard deviation, every single win percentage of every team would be 0.5, right? They win half their games. 0.5 minus 0.5 is 0. Squared is 0. Add that up from every team. Every team would have a 0. My variance and standard deviation would be 0 there, right? So yeah, that's the best I can do. If every team gets 500, wins half their games, or it kind of says, you know, they go 500, right? We would have this, you know, standard deviation or variance of 0, which is, you know, the best we can do, right? So yeah, that's a good question. Any other questions on this, kind of as we're talking about ratios? Okay. All right. So, I did have 2008. This was 2011. I skipped back. I then did some 2018 data as well, right? So you can kind of see what's happened. Looks like, they're all similar. I don't know, they've moved in different directions. So some teams have gotten a little bit better. Some have gotten a little bit worse. What column shouldn't change here? Right? I think maybe with the rounding, it looks like they changed. I think I read this is 0.05 something. So, you know, these ideal standard deviations should be the same. Okay. Now if we look at the ratios, we can kind of see maybe the NBA realized they had an issue. They did improve a little bit, right? Lower the ratio some. And the other ones have kind of stayed similar. But the NFL has kind of taken over the NHL as being the team that we could brag has the best competitive balance. Right? So yeah, you could do this for a bunch of different years. In fact, you know, a lot of projects I see people do, people get interested in this idea of competitive balance, and you might have to start calculating some of these yourself, right? So I want to show you in Excel how we would do that real quick. And it doesn't have, I'm just going to make a toy data set here just so I can show you the actual function. It doesn't really matter that we don't have the real data. Okay. So if I want to do a variance, which, you know, I could, to get the standard deviation, I could then take the square root. I could use that var.s, all right? So that var.s, this is a function in Excel. And I realized I haven't had all of you in 221, so I have to realize some of you may not have a lot of experience in Excel. But whenever we put an equal sign, and then we can tell Excel there's some built-in function that's programmed into you. Okay, that's built into you, and I want you to do something for me. And the reason why I paused there is because the screen went out in class, if those of you who watch on Zoom are kind of wondering. So I then just select the numbers I want to find the variance of. Right? And I put var.s here because we're treating this as kind of sample variance. You could argue that if you are using every single team in the league for that year, you technically have the population data, right? You have every single team for that professional sport. We could actually use the population variance. Right? So instead of var.s, guys, it depends on what we're looking at, right? If we're talking about the competitive balance stuff and I have every team, it's population data. If I only have, 100 of the, I don't know, last, 1,000 players in the league during a certain time period, well, that's only a sample, right? That's just part of the population. So for the competitive balance stuff, most likely you'd be using that population data because you do have every team, right? You should, or I don't know why you wouldn't have data on some teams but not others. So we'll use var.p. That would give us the variance. The other equation that we could use is STDEV, which is the standard deviation, right? Same kind of idea. I just select the observations that I want to find the standard deviation of. Oh. All right. Hit enter, and I can find the standard deviation. Okay. So for your projects, we're starting to think about things with competitive balance, and you might want to, if you have a data set, you want to find some standard deviations. Those are kind of that built-in function that'll do it for you. Okay. All right. So that was a little bit of an aside, but I'm trying to start to think about working things in that kind of relate to some of you might have to do on your project. Some others may not be interested in that. So let's think about kind of competitive balance and the fact that there's diminishing returns at the same position in most sports, right? You can maybe argue that in baseball, the pitching position, there isn't diminishing returns in the sense that it's not like as steep of a drop, but there still would be, right? Because you're still going to go out and get the first pitcher or the best pitcher first, and then the second pitcher would be, whoever you would consider the second best pitcher. So there still is diminishing returns. They just don't fall as quickly as if you add, say, a second quarterback to your team. Right? So we'll kind of use a league where, or a position where we do see a quick drop off because it kind of hits the idea home a little bit better. So what would happen, and I think I kind of was thinking about, yes, this is assuming that Aaron Rodgers stays with Green Bay, but what would happen if they went out and signed kind of a free agent like Cam Newton, right? Well, Cam Newton's arguably he's a decent quarterback. At least he was at one time. I mean, you could fill in the blank here. If we don't like Cam Newton, you could, choose your offseason quarterback who hasn't found a home yet. Well, there's going to be a high cost. Like he's still going to require a decently high contract, but he's just going to be sitting on the bench. He's not going to add a lot of additional wins to my team, right? So if I'm thinking about, what this is going to do for competitive balance, well, let's say the Green Bay had all the money in the world, and let's say, I don't know, we completely blow up the NFL and make every team like join a draft, right? So, the Packers go through the first round, they choose Aaron Rodgers, they go to the second round, there's still a ton of high quality quarterbacks available, and maybe they choose, someone else who's of really, really high quality, right? Well, because that player is not going to add as many additional wins to their team, they're really just hurting themselves, right? They're going to have to spend a lot of money on another top-level quarterback to just have them sit on the bench and not add a lot to improving the quality of the team, right, or increasing the number of wins to the team. Okay? So that probably means the Packers aren't going to use their very second pick on another quarterback. They're probably going to go to another position because if they don't have any high-quality player in that position, going out and getting a high-quality player in that position adds a lot of additional wins, right? So what that means is that they can't stockpile, right? So this is going to prevent these teams from stockpiling high-quality players within the same position, right? Now, one problem we can maybe see arise with this, your brain might start kind of churning if you're interested in other sports, is this can happen in some sport. The one where we probably see this occur a little bit would be Major League Baseball, right? If you've got some team like the Yankees, and some of these teams have, there's no cap to how much they can spend. Well, at a certain point, they're not trying to build their starting lineup. They may be just spending more money to prevent other teams, right, from going out and getting some of those high-quality players. Okay? So it is possible that teams can still stockpile, but this marginal kind of this diminishing returns and the marginal kind of number of wins that a player adds, right, really kind of makes that a lot less likely that teams will stockpile, specifically when you have these really quick drop-offs, right? In Major League Baseball, for like I mentioned, the pitcher position, Well, I can stockpile 5 pitchers. I could get the 5 best pitchers in the league, and guess what? They're all going to add a high number of wins to my team, right? Because I have a 5-man rotation, right? So it's a little bit easier if you want to think about it that way in Major League Baseball to kind of stockpile pitchers because the diminishing returns isn't diminishing as quickly, right? But yeah, that's I think kind of looking at 2 different differences across leagues there, kind of really sells this idea. Okay. So first of all, any questions on that before I keep moving? Is that kind of making sense? The idea? Okay. Oh, so I've already mentioned this, right? More quickly, the difference between NFL kind of quarterbacks and Major League Baseball pitchers. Like that's the real the best 2 examples we have is the position that it makes no sense to stockpile and the position where it probably makes the most sense in these top kind of 4 sports, type 4 professional sports. Okay. So I think up to this point, I've kind of been talking a lot about, and I mentioned a little bit about kind of turnover at the top, but we really just discussed like within season variation, right? Looking at the difference in win percentages for a particular year. Well, what about between season? Well, this usually is when we want to focus a little bit more on kind of turnover in the playoffs, turnover at the top. So there's no real ideal measure like we have for within season variation. What do you want your turnover to be at the top? I mean, you've got a certain number of teams, so I guess you could measure it that way. You could kind of look at, instead of win percentage, the percentage of the playoff percent of the team, but that's going to have to span years. So it's not a real, and then, different seasons have different numbers of teams if you go about far back enough. So there's no real kind of ideal measure that we're going to calculate there. But a lot of the times what we'll do is, well, let's just look at the win percentage of a team for the last 20 years, right? We could get that data and then find the standard deviation of their win percentage over the last, 20 years, right? We could also then look at, right, well, what's the standard deviation and win percentage in the league, and has that changed over time, right? We could do something like that. This is like the only way we can kind of capture how much variation we're seeing in these leagues across years. Okay? We're probably going to be less focused on measures like that and more focused on these turnover measures, right? Are the teams at the top kind of always the same, or are we getting different teams there in the playoffs or as champions, right? Whenever you look at, a lot of research that looks at between season variation, we stop kind of focusing on just the, measures like standard deviation and variance and win percentage, and more on kind of, the teams that are repeating in the playoffs, the number of teams that are repeating as champions, and we'll probably focus a little bit more on those. Okay. So one measure that you might remember a little bit or might recall from 201 would be the HHI, so Herfindahl-Hirschman Index. So usually you're using this to measure like, market power and whether or not, it's all concentrated with one firm or concentrated with a top, couple firms. So here we can apply it, but we're going to kind of look at championships, right? So CI here, we'll initially think about this is the number of championships. Okay. So you're going to go through, and this summation sign means start with, and I actually think let me add something in here because I forgot or I accidentally deleted it. We really should be thinking about that, so I'm going to be mathematically sound as starting with I is equal to 1, right? Start with the very first team. Look at kind of the number of championships maybe that they've won over the certain time period you're looking at. So maybe I'm looking at the last 20 years. N would be 20, right? So I'm going to look at the last 20 years, and for each team, right, I'm going to say how many championships did they win in those 20 years. I'm going to take that ratio and square it. And then I'm going to do that for every single team, okay? So you can imagine if I have, 20 years and I have 20 different teams winning, this is going to be 1 over 20 squared added up, 20 different times. But let's say I have, a situation, and I don't know what that is off the top of my head, but it's going to be pretty low, right? 1 over 20 is what, like 0.05, and you square it, right? And you add, it's going to be relatively low. What happens if a team won the championship every single year of those 20 years, what would this HHI be? What would this Herfindahl-Hirschman index be? So if a team won the championship every year from the last 20 years, let's think about, let's go through this. So we've got every single team. We're going to look at what their ratio is, right? So for the team that won all 20 of the championships, what's this ratio going to be? 20 championships divided by 20 years. So 1 squared is 1. Okay. Well, let's go to the next team. Well, we know they didn't win any championships because only one team won all. So how many championships would they win? 0 out of 20 squared is 0. Every other team is going to have a ratio of 0. So essentially the high, kind of the worst we would see is that this HHI would be 1, right? That would represent that a team won every single year in that time period that we're looking at. Or the same team, sorry, won every single year. And then as we kind of move away from that point, we had an example, maybe 20 different teams won. Could actually calculate that if I wanted to, just so we have a number to say, right? So we would have what? Every team would have a ratio of 1 over 20. Keep my parenthesis in there. We then square that. And then we're going to have that for 20 different teams, or 20 different, let's assume we have a 20-team league just to make it easy, right? We'd end up with a pretty low HHI there. So 1 would be the highest, and then the lowest would be, well, I shouldn't say the lowest, but because it would depend on the number of years. But as it gets lower, right, it's going to kind of move towards 0, right? So 1 would be the highest that we see here, and then kind of better competitive balance would actually be moving closer to 0. So kind of similar to other statistics, really, right? Like as the variance or standard deviation gets closer to 0, we have more competitive balance in the number of wins. As this HHI gets closer to 0, we have more competitive balance in turnover at the top, or who's winning these championships. And you could really do a similar thing here. I didn't put this in the slides at all, but I could do a similar thing here with, I don't know, division winners. It's just instead of CI here, I might call it, I don't know, the division winner. So DWI, that's a nice little acronym. So I could just think about, I'm just replacing championship with the number of whatever I'm interested in. Any questions on this? And I think typically, like in 201, you'll like multiply this by 10,000 just so it's like easier to see. You don't have to do that, all right? So it just scales it, right? So this is might look a little bit different than what you remember. All right, where are we at on time? How much more do I have here? Am I gonna have enough to save? I got a bunch of revenue sharing stuff. So. All right, we'll go a little bit more on this. So I don't want to, not going to make you like compute one of these. So I'm just going to go through this pretty quick. But you might remember, and I don't know if this might be in 202 as well, but I know in 201 they talk about kind of, if you're looking at income inequality, you can use this thing called kind of the Lorenz curve and calculate a Gini coefficient, right? So all this really does is it plots every single usually quantile. Right? You might say the bottom 20% of people only hold 3% of the total income, right? And then the bottom 40% of people might own, the 13% of the income, right? And you just plot these points, right? So here's the bottom 20% and kind of what their income would be. We can do a very similar thing, but with wins, right? The bottom 20% of teams might only have won 13% of the league's games. And then I can think about, well, if I look at the bottom 80% of teams, right, they might have won 63% of the league's games. And I basically just calculate this at each one of these kind of quantiles, right, 20, 40, 60, 80, and then 100%. Well, once I get to 100%, what percent of the games would the bottom 100% of the league have to win? Yeah, 100%, right? Once we get to the top, we're always going to be at 100% and 100%, right? So this line would be a perfect line of equality. The bottom 20% of teams won 20% of the games. The bottom 40% of the teams won 40% of the games. That would be our kind of line of perfect equality in terms of wins. Our Lorenz curve was what it actually was, right? And so the further this gets away from that line, we kind of say the worse or the higher the inequality we have is, or the worse competitive balance is. Okay? The best competitive balance we could hope for is this kind of line of perfect equality. Right? So we could use, So we could use that Gini coefficient, which basically looks at the area that's under this curve. So I had to draw it kind of like right here. And the ratio of that to the area under the perfect line of equality, right? And then we use that just as a measure of how unequal or kind of the teams would be. Right? So I just want to kind of mention that because it is something that I'm sure a lot of you talked about in 201. It is a different measure of competitive balance, but and I have put a paper up for this week that will think about this coefficient. I'm not going to be overly concerned and ask you to calculate it, but you could, right? You could go split the teams up, look at the 20, look at who had the arrange them from lowest number of wins to highest. Look at the bottom 20% of teams, add their wins up, plot that point right here. Then you look at the bottom 40% of teams in terms of wins, add up all their wins, see what the percent of overall kind of league wins it was, plot that point. You could go through and do this by hand. I'm not really going to be kind of asking you to do that. But I do want you to know, once we have that Gini coefficient, right, the closer it gets to 1, right, a Gini coefficient of 1 would mean that our perfect line of equality was actually the same as our Lorenz curve, right? So as we get closer to 1, the closer we're getting to perfect competitive balance. As this moves further and further away, the area under our Lorenz curve is going to get closer and closer to 0. And so as we get a Gini coefficient closer to 0, we have kind of worse competitive balance. All right, so the next topic I want to talk about is the invariance principle. So I don't know if you guys have maybe seen this in the other courses. But the invariance principle is the idea that changing the rights to something doesn't change where the resources end up, just simply who's like receiving the money for them. Okay? So this is the idea that it doesn't matter who starts out owning a certain resource, it's gonna end up with the person that values it the most. Why? Because that's the person, if they value it the most, it brings them the most marginal benefit. They're gonna have the highest demand curve. They're always gonna be willing to pay the highest amount. Well, have the ability and willingness to pay the highest amount, okay? So it doesn't matter who starts out owning it, right? So let's think of an example of this, right? So what did I say? Let's say we got a free market, right? And everybody who values tickets, we'll just pay the single monopoly price for them, right? So there's a monopoly in the ticket market, they charge a price, and whoever values the ticket more than that price will purchase the ticket, right? So if instead tickets are given through a lottery, so this is just kind of our basic scenario, right? People who value it more than that monopoly price will be the ones who go out and purchase it and then end up with the tickets, right? If instead we do a lottery system, right? And some people end up with the tickets, right? They're just kind of random. It's not so that they are kind of paying a price, they just end up with the tickets, right? So the property rights are kind of given out randomly. It could be that people who value them below the monopoly price then say, well, look, I received these tickets in a lottery. I got them for free, right? I don't value them that much. Maybe I only value it, $10. If someone's willing to give me $20 for it, I would sell it to them, right? And then people who do not get a ticket in the lottery, right, who value it above whatever the monopoly price would be, they'd be willing to pay for that ticket still, right? So it doesn't matter that the property rights were given to people who valued the tickets lower, because they'll just turn around and sell them to the person who valued it higher. It didn't matter where the property rights started. Okay? So the only time this would break down is if we have really high transaction costs. So I'm going to try to give you an example here. So let's say, kind of most simple, the simple form of this. So let's say we had some demand curve and we've got kind of our ticket market, right? So let's say that I just assign, well, let's say we've got some monopoly. Here's my marginal costs. Oh, I'm doing the ticket market. Ignore supply. We got something out here. So we would go, right, we've got the vertical line. Right? And I don't know, the price the monopolist sets is, let's just say it's $20 to make it easy. Right? So the price, the kind of going price for this ticket out there is $20, right? Somehow someone like, I don't know, calls into a radio station and the prize for the day is whatever game this ticket is going to, right? And this is the person that called into that radio station, right? So yeah, if it's a relatively low cost to call into the radio station, they still value having that ticket, and maybe they value it at $10, right? So this is the person who like gets that ticket in the lottery. Right? Well, there's somebody up here, right, that values having a ticket at $30, right? Or you can think about there's different demand curves. So the price is 20. We'll kind of call it that person one. Oh, person one who received the ticket in the lottery values it at 10, and person two kind of values it at 30. Well, what's going to happen? Person one looks at this and says, well, yeah, we can agree that I'll sell you this ticket for $20 because I don't value it that high, right? So I'll sell that ticket to you for $20, right? I'll receive the $20. I won't have the ticket anymore, right? So I'll lose out on that 10, but I'm still kind of net $10 there, right? Person two, right? They're going to get a marginal benefit of 30. They're going to pay that $20 to the other person. And so kind of both parties are better off, right? They both kind of netted a positive amount here from this transaction, okay? Questions on that? All right. So they both kind of had this you know, positive for both of them to do this. And the person who valued it more ended up with a ticket, right? That's the kind of the clincher here is it didn't matter who started out with a property rights. It didn't matter who owned the ticket. Whoever values it more will always be willing to kind of pay for it, like pay more for it. So what happens if instead we have, I don't know, let's say they're using some service. This is a little bit of a wild kind of example, but let's say they charge $20 for you to sell your tickets through their like app or whatever, right? And I'm doing this only because I'm choosing these numbers. Like the actual numbers are going to be a lot different. But if the transaction costs are $20, well, now when we try to come up with this agreement, if person two buys this ticket, they get a marginal benefit of $30, right? That's how much they value it. But they have to pay the ticket cost, right? So they have to pay the ticket cost, but they also are going to have to pay this transaction cost, right? So now they're at a point where, well, yeah, now it doesn't make any sense for me to try to purchase this ticket because I'm going to have a net negative gain. Right? So if we have really high transaction costs, it can kind of prevent the invariance principle from working because under this scenario, person two isn't going to want to purchase the ticket, and person one will just keep it, right? And it wouldn't be beneficial for person two either, right? Because once they sell that ticket, they get $20. So this was kind of person two. We'll think about here was person one. They get a marginal benefit. You know, when they sell the ticket, they would get $20, right? They lose out on the marginal benefit of keeping the ticket. But now they have to pay this additional transaction cost through this app as well. So you can kind of think about here, their net gain will be negative 10 as well. Right? So the transaction costs get high enough, it breaks down either one of these people from wanting to make a deal, and the person who had the property rights actually just gets to keep it. Okay? But if we keep these transaction costs low, like let's say we still have to operate through an app, but let's say instead of $20 as a transaction cost, it's only $5. Well, now if I do the math right, I think they both should net 5, and they would still make that deal, right? Any questions on this? I know this is a little bit, probably could have kind of used a little bit better notation here, but kind of explaining the idea was actually being able to see some numbers I think helps, okay? We're okay with this? All right. So we can also apply this idea of the invariance principle to free agency, okay? So players, if we think about if we have free agency, players are allowed to kind of sign deals with whoever they want when they're a free agent. Players are going to get paid by the team who values them most, right? If there's a free agent sitting out there, they're going to, all else equal, like similar quality programs, they're going to choose the program that kind of values them the most and is willing to pay them the most, okay? Without free agency, what happens? Well, if you have a player, right, and he's currently on a team, and that team, let's use the kind of backup quarterback example, right? So if I've got 2 really high quality quarterbacks, right, and one of them isn't really, my second best quarterback is just sitting the bench, I don't have a high value to them, right? They're not bringing a lot of value to my team. They're not increasing the number of wins very much. And so I'm not willing to pay them near as much as a team who doesn't have a quarterback might. I actually heard right before this class, a good current example is the Eagles just traded Carson Wentz, right? They've got Jalen Hurts. They think he's the guy. And so they don't want to, pay him. They don't value Carson Wentz as much as to sit the bench. So there's another team, the Colts, value him a lot more. So what happens, even without free agency, right? He wasn't a free agent. What happens is that player gets traded to whatever team values him the most and is willing to give, right, the most to that team to make that trade, right? So it doesn't matter who has the property rights. It doesn't matter if it's the team. It doesn't matter if the player isn't owned by anyone, right? They would still end up with that team that values them the most, okay? So we see that in free agency, in either scenario. Now, the reserve clause still allowed for players to be traded, right? So it wasn't that when we were talking last class about that reserve clause where if the teams owned the right to the player, right, they couldn't go out and sign a deal with anyone else, even after their contract was up, right? But they could still trade them. So if teams did value that player, the invariance principle says it doesn't matter that we have the reserve clause, that player should still end up on the team that values them the most. The only problem is, with the reserve clause, right, it's that when that player gets traded, right, they may, not receive as much money as if they would have had free agency, and the team who's trading them is the one getting kind of all this, right? Instead of giving a higher wage to the player they're trading for, they're giving away like picks or money or something to the team that they're trying to get the player from. So the invariance principle doesn't break down with the reserve clause, but we still have the case from that reserve clause where the players aren't getting the resources the actual teams are. And resources here are really thinking about, the dollar worth of those resources, okay? Whether they're picks or actual cash, okay? And I kind of already talked about the idea that it breaks down with transaction costs. So what might be some transaction costs that exist in sports? Well, even if I value a certain player more than every other team, if currently if my league has like a salary cap or something where I have to pay more money if I go over it, if I'm currently at that cap and trading for that player, even though I value them the most, I have this additional cost or this additional transaction cost, which is I have to pay this luxury tax. If that luxury tax is high enough, it could break down the invariance principle when it comes to things like free agency and kind of who owns the current rights to a player. Any questions on that before we keep moving from here? All right, so I think we'll pick up next class. We've done some revenue sharing stuff, but we'll go through revenue sharing, some more ideas related to revenue sharing next class. We'll do some salary cap stuff next week. Thought we'd get a little bit further, but I do want to kind of think about this paper. So I posted 2 papers this week. We'll kind of do a little bit of a dive into each of them, okay? So the first one was this Tiger Woods paper, right? So I don't know if anyone took a look at it, but it's a relatively interesting paper, right? And it kind of relates to this idea of competitive balance to a degree, right? So the idea of this paper is that, when Phil Mickelson goes up against Tiger Woods, as opposed to maybe, I don't know, me, right? He's going to try a little bit harder, right? Because if he wants to win, he's going to, knows he has to be a little more focused when he's playing another professional as opposed to kind of an amateur. Right? So the idea is that the effort that a player puts in may depend on their opponent, right? I think if you listen to any type of sports talk, they talk about this, teams playing down other teams, and it's this idea that if my opponent isn't a very high quality, I might not put in as much effort. Right? It also works the reverse way, right? If I'm Tiger Woods, I don't put in as well. I guess it would be the same thing, right? So both players, whoever's of higher quality. If my opponent is of a similar quality to me, I might put in more effort. Right? If they're lower quality to me, I might put in less. Okay? But let's think about it this way. What about the amateur in this situation? I think I said me. If Phil Mickelson or Tiger Woods played me, what kind of effort do you think I'm going to put in? I could care less, right? Like, I would want to win, but I know my odds of winning are so low that the benefit that the additional effort will bring to me is essentially zero, right? It's just going to cost me additional time or kind of focus, whatever. So for those amateurs, those really low quality players, when they go up against higher quality players, they're going to put in less effort as well. So what might you get? You might get like both people putting in less effort and a lower quality product. Now I'm using extremes here, right? So, but this is the general idea. So kind of what they did in this paper was looked at, okay, when players went up against Tiger Woods, right, if their relative ability to Tiger Woods was close, did they put in more effort or less effort? This was the idea that, well, those who are pretty close to his quality might actually increase their effort to try to beat him. But for those who had relative ability much, much worse than him, they might put in less effort. So we had here, right, on the y-axis, was effort that they're putting in, right, or kind of their performance. We're kind of only measuring their effort based off of performance. As my relative ability gets much, much worse, compared to Tiger Woods, we see much lower levels of effort put in than those who have relative ability measures that are really close to them, right? If we try to follow this kind of black line. That's kind of what this graph in the paper is trying to get at. I won't focus on that too much. So what they're going to do is this first table is really looking at, I think this is just the averages, right? Yeah, so they kind of just broke this down to the averages. So when a golfer was playing with Tiger Woods versus without, what was the average number of eagles, average number of birdies, so on and so forth, right? So you kind of look here, there's not a lot of differences in the averages, and so, well, maybe players play the same regardless if they're going up against a high-quality opponent or not. Right? But just comparing averages isn't a great way to look at this, okay? So what we're going to do instead, right, is run a linear regression, right? A regression allows us to account for and control for more factors, okay? So what they did was they do something where they create interactions between two variables, right? So the variables we have here are whether or not they're going up against a star player, right? Kind of star here really was just a 1 or a 0. And really the paper focuses mainly on, were they playing against Tiger Woods or were they not? So you could almost replace the word star here with Tiger Woods. So it was a 1 if the observation and the data was coming from a player who was playing in a tournament against Tiger Woods, a 0 if they were in a tournament where they weren't playing against Tiger Woods, right? They then had to measure, was the player highly ranked or were they low ranked or even unranked, right? So just 1s or 0s, right? So the only way, right, if we're trying to use this linear regression and we're thinking about this coefficient beta 1 here, the only time that we would kind of think about beta 1 actually having an effect is if both of these are 1s. Because if either of them are 0, 0 times anything is 0. Right? So beta 1 here would represent the effect or the either increase or decrease in the number of strokes that they have over that kind of 18-hole game if they're going up against Tiger Woods and they're highly ranked. And then beta 2 would be the additional strokes or kind of decrease that you would expect if they're going up against Tiger Woods and they're low ranked, right? And kind of beta 3 if they're going up against Tiger Woods and they're unranked. Okay? It would have to be, well, both ones. Okay. They then just controlled for whether or not the player was high or low ranked, right? Because if I'm high or low ranked, that's going to give me some measure of just the quality of the player, like not the additional effect that comes from going up against Tiger Woods. And they had a bunch of other, I forget all the controls here, but they have like year controls, course, like which course it was on, weather controls is another one they added in there. So they tried to account for a lot of other factors. So, what would we expect here? Well, if the story I was telling was true, like we would expect when the high-ranked players go up against Tiger Woods that they actually do better. So their number of strokes would actually go down. It's kind of weird because in golf, the lower number is actually better here. And then for maybe like unranked players, they're so far away from being able to beat Tiger Woods that once they go up against him, the additional kind of number of strokes, maybe it's positive, right? Because they just stop caring. They know they're not going to win. They just stop caring. Okay? So if we look at the kind of results, right? We have ranked, high ranked, low ranked, unranked. You can see here that in the first round, it actually kind of goes a little bit against our intuition, where even really, really high ranked players actually saw an increase in their number of strokes, right? So this paper, what they're trying to sell is like this idea that you would expect that even like the high-ranked players would put in a little more effort because they'd really want to beat Tiger Woods. And it must have been that he was so dominant at this time that even highly ranked players actually performed worse against him. And they use this as an indicator of effort, right? Now, it's not perfect, right? It's not a perfect measure of effort, but if we're controlling for kind of what their ranking is, and that ranking is based off of previous performance, right? Well, it's almost like we're holding that constant. The thought experiment is two people who have the exact same ranking, so that is based off the exact same previous performance. They're same weather conditions, they're on the same golf course, but one of them is golfing against Tiger Woods. That individual actually performs worse, right? And so what's explaining that? Well, we've controlled for so much else. It must be that performance decrease was coming from a decrease in effort. Right? Now, I mean, this isn't, I would argue this is, like I said, it's not the perfect measure of effort, but sometimes when we have a question where we don't have the perfect data set. We don't have a variable here, which is effort, right? All we can observe is this proxy for effort, which is performance. And that applies to a lot of different scenarios. So a lot of you, a couple of you emailed me. I'm not doing a great job getting the data sets out there. So I'm hoping after I get all those proposals, a lot of you guys should start shooting emails out next week. I've got a bunch of like partial data sets sitting around a folder on my computer. So a lot of you will start getting those here pretty soon, but they may not be your perfect data set, right? The variables may not be perfect for what you want to get at. So here, this is good evidence that potentially all these players are seeing a decrease kind of in their effort when they go up against Tiger. But it's not, you can also identify the holes that might exist in this story or the kind of imperfection that exists in this type of data analysis to answer your question. So it's okay, like when you're writing your papers or your projects, don't think about it as like you have this question, you have the economic theory that would predict or kind of what you would expect to see, and then you're going to have the best data source available to you to try to analyze that. Now, the results of that data analysis will suggest, right, an answer to that question, but if it doesn't perfectly match up with maybe what the economic theory predicted, you also have to stop and think and recognize what the holes in the data you had could have been, or even in just your approach. Like, well, maybe I wasn't able to control for the weather conditions in this. Like they did, but maybe if they weren't able to, they could say, well, look, we found evidence that goes against this, but we didn't have this really other important control, which is what the weather conditions were for every single game. Right? So it's okay to acknowledge those. I guess is what I'm kind of getting at. And they tried to look at whether players were kind of, maybe it wasn't that they were putting in less effort. Maybe they were being like really risky, right? Maybe they were like, and I'm gonna have to play really good to beat him. So like, I'm not gonna, kind of take the easy shot. I'm going for, a really, really difficult shot. And if I miss it, I'm ending up, in the bunker. I'm ending up in the pond or whatever. But if I can hit it, I'm going to gain a stroke or two, right? So they tried to investigate some of that, and they actually found that kind of the variation, that's what they use, the variation of strokes relative to the par here. They found that some of these really low-ranked players, notice here we see some stars. I've mentioned this in the past. That means that these were statistically different from zero, statistically significant. They did find that there's like a little bit of maybe some of this riskier behavior for people down at the bottom, because they might have realized like, yeah, I have no chance. Like, I'm just going to Hail Mary on this, kind of. So maybe some of that going on, but for the ranked players, nothing was significant there. So it wasn't operating just through risky behavior. So that was some interesting findings that they had as well. Any questions on this idea, or kind of anything? Like, anytime I'm going through these papers, like I am trying to get you the central theme of the paper, but I'm also trying to mention some of the stuff they did data-wise. So I from week to week, I'll try to mention some of the same things over and over, like mentioning that these stars kind of represent significance, right? We said that, they can be significant at the 10, 5, and 1% level, or that's 90, 95, 99% confidence. We could say it's different than zero, right? These estimates were representing the predicted value for that coefficient, right? We start out assuming that all the coefficients are zero. Okay? We start out assuming that the relationship between this y variable and all these x variables, we start assuming the relationship does not exist, or that those coefficients are zero, right? Doesn't matter that they were going up against the superstar Tiger Woods and they were highly ranked. That effect on the number of strokes was zero. That's what we start out assuming. We then use the data to run that linear regression to come up with, based on the data, what's the predicted relationship, right? But it's still just sample data, right? So it's still a prediction. And we see that there's a positive value there, right? 0.596, right? But, based on the variation that we saw in the data, maybe we can't say that that's statistically significantly different from zero, right? But for this one, we actually can, right? We had we go back, we have a p-value that must have been somewhere between 0.01 and 0.05, because it would be less than the alpha of 0.1 and 0.5, which would be that it is significant at the 10 and 5% level, but it wasn't significant at the 99% level. That's why we don't have 3 stars here. So we can say it's statistically significantly different from zero. But for these down here, notice we don't have stars. So even though they're positive amounts, and they are evidence that potentially that there was, some increase in the number of strokes for these low-ranked and unranked players, we can't statistically, at the 90% level even, say that it's different from zero, that there's any relationship between playing against Tiger Woods and those low-ranked or unranked players. But we can say it for those top-ranked players. Okay. Any questions related to any of that? I'm hoping to be able to hand back homework assignments on Tuesday and have those graded. So some of you will start seeing comments pop up on Canvas. I'll try to save them so I'm not posting multiple comments and I'm only kind of posting one with all the errors that were made. But if you want like I can hand back your physical copy if you want it after they're graded, so that you can kind of go through it and then look at the comments and see what you got wrong. But I also posted an answer key, so you can also even before I give them back to you, you can go through and kind of see what the kind of correct kind of graph should have looked like. And if you have any questions as you're looking at that, or any of the comments you see once you kind of once I hand those back to you, if you want them, and if you're in person in class, then feel free to ask me questions on any of the grading. But that should be done by Tuesday. Okay. All right. Any questions before we wrap it up here today? Nothing in the chat. All right. Well, have a safe, fun, weekend. Try to stay warm, and I will see you guys on Tuesday. Also, I won't do online quiz today, so you'll have